With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, question is when N2O5 is heated at a certain temperature, it dissociates as N2O5 dissociates into N2O3 and oxygen. Kc for this reaction is 2.5. At the same time, N2O3 also decomposes as N2O and into oxygen. If initially 4 moles of N2O5 are taken in 1 liter flask and allowed to dissociate, the concentration of oxygen at equilibrium is 2.5 molar. So equilibrium concentration of N2O5 is. So in this question it is given that N2O5 it dissociates at certain temperature to this, that is into N2O3 and oxygen, and equilibrium constant for this reaction is given. At the same time, the formed N2O3 it also dissociates into N2O and oxygen further, and initially 4 moles of N2O5 are given, and at equilibrium the concentration of oxygen is given as 2.5 molar. So we have to find out the equilibrium concentration of N2O5. So first reaction is N2O5 gaseous. It is giving N2O3 gas plus oxygen gas, and the other reaction is N2O3 then further decomposed to N2O and in oxygen gas. Now if initially at time t is equals to 0, its 4 moles are taken, so they will be 0, and at equilibrium if its x moles will dissociate, so x moles of N2O3 and x moles of oxygen will form. Now let's say for N2O3 initial moles will be x because it is formed in x amount. So for this equilibrium at initial conditions they will form 0, and at equilibrium conditions again let's say it will dissociate into y amount. So y amount of N2 and y of oxygen will be formed. It means the total amount of N2O3 would be x minus y because it is x minus y, and the total amount of oxygen is x is here and y is here, so it will be x plus y. So now we can find the Kc value, that is the equilibrium constant for this. So equilibrium constant Kc is the concentration of the products raised to power their stoichiometric coefficient and divided by the concentration of reactants raised to power stoichiometric coefficient. Now for this reaction the products are N2O3 and oxygen and the reactant is N2O5, and the Kc value for this is also given. So if we write Kc for this reaction, it would be Kc would be concentration of N2O3 and concentration of oxygen divided by the concentration of N2O5. Now concentration is calculated as number of moles upon volume of the flask or the vessel on which the reaction is taking place, but the volume is given 1 liter. It means if volume is given 1 liter, so concentration will be equal to the number of moles. So these are the number of moles, so we can write it as concentration in Kc. So N2O3 its concentration is x minus y, and concentration of O2 is x plus y, and the concentration of N2O5 is at equilibrium is 4 minus x, and the Kc is equal to 2.5. So this will be equals to 2.5 equals to x minus y into x plus y divided by 4 minus x. Now it is also given that the concentration of oxygen at equilibrium is 2.5 molar. It means we have given x plus y equals to 2.5 because the concentration of oxygen at equilibrium is x plus y, so it will be equal to 2.5. Now if we put x plus y is equals to 2.5 here, so it will be x minus y into 2.5 divided by 4 minus x. So this 2.5 will be cancelled. So we will get 1 equals to x minus y upon 4x. So that will be equals to 4 minus x equals to x minus y. Or we can say 4 plus y equals to 2x. Now x plus y is equals to 2.5. So y equals to 2.5 minus x. If you put this value here of y, that will be 4 plus 2.5 minus x equals to 2x. So it will be 6.5 minus x equals to 2x, and this x will go to right side, will become 3x. So 6.5 divided by 3 equals to x, and it is equals to 2.166. So this value is this, but we have to find out the equilibrium concentration of N2O5, and this concentration is 4 minus x because the volume is 1 liter, so number of moles is equal to concentration. So 4 minus x would be equilibrium concentration of N2O5 is 4 minus x, that is 4 minus 2.166, and that is equals to 1.837, or that is equals to 1.84 approximately. So the correct answer to this question is D option, 1.846, which is approximately 1.84. So this answer is the correct answer. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.